today's topic discussion. It is Monte Carlo simulation. So there are few of the other types of simulation as well, but in our syllabus it is specifically mentioned that we need to have Monte Carlo simulation. One of the one of the most usable techniques nowadays is Monte Carlo simulation, and one is about molecular dynamics, right? So molecular dynamics and all that is not for it has limited application, but Monte Carlo can be used at various levels, and we are going to see it in detail in the form of a numerical as well, right? What is this Monte Carlo simulation? You have heard this name before also. Monte Carlo is a name of a city, right? It's a famous city, and it's famous for the casinos as well, right? So the two mathematicians, John von Neumann and the Stanislaw Ulam, they particularly had named this simulation technique as Monte Carlo, or they have given this code to this technique as Monte Carlo. So this technique was developed by these two mathematicians, John von Neumann and Stanislaw Ulam, during World War II. And yesterday only we have seen they have used this technique of simulation, and that was nothing but the Monte Carlo simulation only. And they were doing it for the preparation or of the nuclear shielding material, and then they extensively use this for the atomic bombs as well, right? So these are this has been used for the purpose of devastation as well, right? So what is this Monte Carlo simulation? It employs the random numbers, and it is used to solve problems that involve the probability, and wherein physical experimentation is impracticable and formulation of the mathematical model is impossible. So this is very important. It employs the random number, and it is used to solve the problems that involve the probability. So for the same set of random numbers, you all will be getting the same answer. But if you employ different set of random numbers, you all may get the different answers, because this particular technique is totally dependent upon the random numbers, and it tries to put randomness into the selection, or randomness in getting the answer. For example, everyone would have seen a roulette in a casino, right? A roulette is a device. So I don't know if you have seen a roulette. I think now this particular image is visible to you. So this particular, the circular disc is nothing but the roulette, and what does this do is that every time you spin this disc, they throw a ball, a steel ball, a small steel ball into it, and this particular, when this disc stops spinning, the ball get into one of these spaces on which the number is written, and the guy who has selected that number will win some money. So right, so this every time this roulette is spin, and it will be generating some random numbers, right? So every time you are spinning and stopping, so every time you'll be getting a new number, and that is nothing but how this Monte Carlo simulation works. So it particularly uses the random numbers for doing this simulation technique. So for the same set of the random numbers, you'll be getting the same for the same set of random numbers, you'll be getting the same values of simulation, and if the random numbers are different, you will be definitely getting it different. So what we'll have to do is select the measure of the effectiveness. That is nothing but the objective functions will have to take into consideration. After that, we'll have to identify the variables that are affecting the objective functions significantly. There can be many variables, but only those variables which are affecting it significantly are to be considered. Then what we are going to do is we are now going to determine the cumulative probability distribution of each variable that we have selected in the above step, that is in step B. Now what we are going to do is we are interested in finding out what is the cumulative probability distribution curve. So we'll be putting on x-axis the values of the variables, and on the y-axis we'll be putting the cumulative probability distribution. So after now we'll be plotting the curve, and the curve is called as the probability or cumulative probability distribution. We'll have to identify the set of random numbers in the numerical that we are going to solve for the university question answers. For university problems, we'll be getting the we'll be directly given this set of random numbers, but I'll be also taking one of the numerical in the case if the random numbers are no, told to be generated to you. So what happens in that particular case, that also I'm going to cover with. But in today's numerical, we are going to see a numerical in which our random numbers are already given to us. Now what we are going to do is, now next step is consider each random number as a decimal value for the cumulative distribution. Now enter the cumulative distribution plot along the y-axis. Now project this point horizontally till it meets the distribution curve. So what we are going to do is every the cumulative probability distribution point we are going to consider, we are going to project this point horizontally till it meets the distribution curve, and that particular then project that particular point down on the x-axis. So this we'll have to repeat numerous times till the satisfied number of iterations are available. So now I'm not I'm not going to explain you this highlighted point in much deeper sense, because it is just a generalized way of telling you how the Monte Carlo simulation works. We'll be actually seeing in the numerical, and we will be amazed to know that what we have seen up till now, it only until the identification of the random numbers, these steps matches, and other steps particularly will have to handle in some different manner, right? So the representation of these steps or the explanation of these steps has been given in the graphical context, but here when we try to solve the numerical, that particular graphical context do not hold good. We'll have to do some mathematical calculations, and because of that I'm not going to devote much time on that. We'll be seeing the numerical, and via numerical I'll be making you understand how this simulation will be working. So I've taken a very simple numerical to go ahead with. So this is the numerical wherein it has been given that a bakery keep stock of a popular brand of a cake, and daily demand on past experience is given below. So the bakery is there, say particularly say a small bakery who is keeping a brand of a cake named Monte, right? So they are keeping this particular brand, and the daily demand of that particular brand on the past experience has been given below. So right, so the daily demand, if the probability that there are 0 cakes that are sold for that brand is 0.01, right? So there is only 1% chance that there will be no cake of that particular brand sold for that particular day or any day. So for now, the probability that the 15 cakes of that brand will be sold in a particular or on a given day is 0.15, right? So you can say that there is a 15% chance that 15 cakes will be sold of that brand on any given day. Similarly, for 25 cakes, they have the probability given as 0.20. The for the 35 cakes, it is 0.5. For 45 cakes, it is 0.12, and for 50 cakes, it is 0.02, right? So this is how they have given us the data. Now, we are enough knowledgeable to understand the addition of all this probability should be 1, right? So if you do the addition of all these probability values, the addition should fetch you the number 1. So this daily demand and the probability of the daily demand from some past experiences given to us, and on the basis of that, what we'll have to do is they have asked us using the sequence simulate the demand for the next 10 days. For the next 10 days, they're asking us what should be what should be the demand for the next 10 days. That way that they are asking us, Also, they are asking find the stock situation. If the owner of the bakery decides to make 35 cakes every day, also estimate the daily average demand of the cakes on the basis of the simulated data. Right. So these are the two things that we have been asked. Now in entire numerical, you won't be seeing a single word that they are saying that this is your objective function, maximize this objective function, minimize this objective function. No, here they haven't given the data in terms of objective function, or no, they haven't told us this, minimize this, maximize this. Nothing has been given except this particular past data. And what have been we have been given more is the set of the random numbers. So now this is the set of the random numbers that we have, and we are going to use this set of random numbers to simulate this particular values for the next 10 days. Now we require the values, we require 10 values, right? So we have 10 days in our hand, 10 days for which we'll have to simulate the values, and hence the number of the random numbers should be also 10. So if you count the number, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 random numbers, and these 10 random numbers are why these are only 10 random numbers, because we have been asked to simulate the demand for the next 10 days, right? Again, it would have been like 20 days. If it would have been like 20, we'll have to simulate the demand for next 20 days. We should have 20 random numbers with us, and because then only we can simulate that particular demand. So that is also important. Again, if you see, I'll be making you understand more about this random numbers when we talk about the talk about this numerical. But I'm hoping that you have understood what has been asked. They are asking us they are asking us what will be the demand for the next day. So we have to simulate that particular demand. And they have also asked us, if the irrespective of the demand, if the bakery owner decides to make 35 cakes every day, what will be the stock situation for the 10 days in that bakery? And we have been also asked the average demand of the cakes on the basis of the simulated data. So these are few things that we have asked, like three things that we have asked, and that will be trying to solve. So now what is the first step? What we will be doing is that we are going to allocate the number of the random numbers to the demand of the cake. So I have written here the very first step is the allocation of the random numbers. What you can say at this particular juncture, it is the allocation of the random numbers to the demand of the cake. But for different numerical, it can be different. So for a generalized, you can say that the title of this generalized the generalized title for this step is the allocation of a random number, right? So now let's try and solve this numerical. So what is the demand that I am trying to show it in the form of a table? It is advisable to you to put it in the form of table only. Then only this particular numerical is easy to understand and evaluate as well. So demand, what we have is demand of 0, 15, 25, 35, 45, and 50 cakes, and the probability against the demand has been given to us. So this is nothing but the input values only, but I had made it into I put it in the vertical fashion rather than in the horizontal fashion. So for 0 cakes, the probability was 0.01. Similarly, for 35, it is 0.50. So this is nothing but the input. Next step is now we'll have to find out what is the cumulative probability. So when we are thinking of the cumulative probability, addition of all this in the cumulative fashion we'll have to do. So the first value we have is 0.01. Next value we have is 0.15, but we'll have to add this two values now. So it will be 0.16, right? So next cumulative value is 0.16 plus 0.20. That happens to be 0.36. Next cumulative value is 0.36 plus 0.50, which happens to come as 0.86. Next cumulative value is 0.86 plus 0.12, which happens to come as 0.98. And next cumulative value is 0.98 plus 0.02. And the this particular cumulative probability comes out to be 1, right? So it should come 1 because it is the probability, right? So again, we have done this addition. Now what we have to do is we have to decide the random number interval before placing the allocation of the random numbers. This particular step is very, very important. All right. Now what we have been given to us, what they have given us result, the probability is 1. So the placement of the random numbers will be thinking that let's start to give the random number from 0. We won't be starting it to give it from 1. The 0 is also a random number, so we particularly will start to place the random number starting from 0. So now we have here 1 probability. That means that we'll have to place only 1 number here, and that happens to be 0, right? Next we have the probability of 15 here, 15 number, 15%. So we'll have to place how many? We'll have to place we will have to have 15 random numbers, and the 15 random numbers. So first random number particularly no, my mistake. Here we have 1 as a digit, so particularly there will be only 1 random number that will be allocated. Nextly, we'll have to go for 15 as we'll have to think of 15 as 15 numbers. So we'll have to put it as into in the format of 1 to 15, right? Next random numbers, how many random numbers we have? We have 20 random numbers. So here it were like 15 was given here, so here we'll be having only 15 random numbers starting from 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15. These are the 15 random numbers, and the interval has been denoted by 1-15, right? Next we have 20 as the probability here that has been given, so we'll have to allocate 20 random numbers, right? So 20 random numbers starting from 16, right? So up till 15 we have already allocated, right? But now here the random interval for this particular for the next step will be starting from 16 and till 20 more numbers. So starting from 16 to 35, these are the 20 numbers, right? So this is the range that we have allocated. Next range what we have is the next probability we have been given as 50. So we'll have to employ 50 random numbers starting from 36, because till 35 we have already allocated the interval. So it is now from 36 to 85. So if you take into consideration, these are the 50 random 50 random numbers that we have been the random interval we have put here. Next is the probability that we have is 12, and we'll have to go for 12 random numbers starting from 86. So if you try to recall or count the numbers, so it is 86, 87, 88, 89, 90, 91, 92, 93, 94, 95, 96, and 97. So these are the 12 numbers that we have allocated. Here now we have the probability as 2, and we are going to allocate only 2 numbers, random numbers here. So it happens to be 98 and 99. So the random numbers, that the complete set of random numbers, that we have is from 0 to 99. So we have the numbers from 0 to 99, or any number between 0 to 99 can act as a random number to us. But we have been given the random numbers here, right? We have been given the random numbers here, and if you see properly, all these random numbers are between 0 to 99. Right, here also we require the number from the random number interval. From the cumulative random number interval is 0 to 99, and all your random numbers here should also be between 0 to 99 only, and that has been followed. So the random number is 0 to, they have been given, they have told us the random numbers are this, right? And accordingly we are going to solve. Now first random number is 48, right? So this 48 falls in which random interval? The 48 falls in this random interval. So it is between 36 to 85. So I have written here 48, and in bracket I have written 1, because this was our first random number, right? The next random number which has been asked to us is 78. Again 78 falls between 36 to 85, and I've put it in this particular column, which is 78, and in bracket I've written it as 2. The next random number is 09, and the 9 now falls in the range of 1 to 15, and I have put here the random number, which is 9, and in bracket I have kept it as 3. Right. Next is now random number is 51. The 51 falls in this particular interval 36 to 85. I put it here and I placed this 51 in bracket 4. Right. Nextly 56 we have. 56 again lies in 36 to 85, and I put it here. The next random number that we have is 77. 77 again falls in 36 to 85. So the placement of 77 is done here. The next random number that has been given to us is 14. 14 falls in range of 1 to 15, and it has been placed in this particular cell. The next random number that we have been told is 68, and 68 happens to fall in the range of 36 to 85, hence it has been placed here. And the very last random number that we have is 9, and it falls in the category of 1 to 15, and hence it has been placed in this particular cell. Now what we are going to do is, now particularly 48 that represents our day 1, right? Here 78 that particularly is the random number that will be representing our day 2. So all this particular every random number here in the sequence is going to represent that particular day. So we have 10 days, so 10 random numbers. 48 is for first random 48 random number is for first day, 78 random number is for second, 9 for third, 51 for fourth, 56 for fifth, 77 for sixth, 15 for seventh, 14 for eighth, 68 for ninth, and 9 for 10th day respectively. So all these are these are the random numbers associated with their respective days. So for 48, if you see, the 48 happens to be first day, and the the number of cakes that needs to be the number of cake will have to we have been asked to simulate the cake demand. So the cake demand for your first day will be how much? It will be 35, because it has been particularly, it falls in this particular row. So all these values which are falling, all these days which falls in this row will have the cake demand as 35 for that particular day, right? So here for first day it is 35 days. For second day again it is 35 days. For third day it will be how much? It will be 15 days, because now here the third day falls in this particular category. So here the third day will have 15 cake demand. Fourth day again will have a 35 cake demand. 45th day will have a 35 cake demand. Sixth day will have a 76 cake demand. Seventh day will have a 15 cake demand. Eighth day will have a 15 cake demand, and ninth day will have 68. Ninth day will have 35 cake demand, and your last 10th day will have 15 cake demand. So you can write the number of cakes demand in the next 10 days can be given in this particular fashion. It is 35, 35, 15, 35, 35, 35, 15, 15, 35, 15 respectively. So this now solves our, or this answers our first question, that is simulate the cake demand for 10 days. Now this is how this particular Monte Carlo technique works, right? So if you have different set of random numbers here, your answer will be definitely different. But to match with the answer, this particular thing has been given. Again, the selection of the random numbers is also one of the trick that they say, and I'll be throwing light on this particular aspect in few of the numericals ahead. But now let's solve our numerical further. We have been asked what is the stock situation if the 35 cakes are made every day. Now if this is the demand for next 10 days. But irrespective of the demand, the bakery owner is deciding to have 35 cakes per day. No, he is not worried about the demand. So we'll have to think of the what is the stock situation. So let's then analyze the stock situation. So for day 1 to 10, I have written here. I have the demand for each day, which has been copied from here only, right? So 35, 35, 15. 35, 35, 35, 15, 15, 35, 15. So this is the cake demand. I've written it vertically here. Now, how many cakes the owner owner has decided to make irrespective of the demand. He is deciding to go with 35 cakes every day. Now, on the day 1, there is a demand of 35 cakes, and the number of cakes that are made are 35. So there will be zero stock that will be available, right? On the second day, there are again 35 cakes that are demanded, and he had made 35 cakes, and hence the stock situation stands as nil, that is zero. Now on the third day, the demand is of only 15 cakes, but the owner had made 35 cakes, right? So what will happen? The 20 cakes will remain in the stock, right? Now the next fourth day, 35 cakes were ordered, and the 35 cakes were made. So the demand and supplies is matching. But previously the stock had 20 number of cakes. The same stock situation, the same stock is carried forward, because we have been asked the stock situation for 10 days. So like this particularly is now this particular 20 values only carried forward, and here it is now 20 cakes that are remaining of the earlier day only. For the fifth day as well, there are 35 cakes demanded, 35 cakes made, but the the 20 cakes are still in the demand, and that particular cakes are pending in our stock. Right. For the sixth day, there is 35 demanded, 35 made. So there is again 20 that is pending with us. For seventh day, there is 15 cakes that are been demanded, and we had made 35 cakes, that is surplus. So how many cakes? 20 cakes are they are not they are going to enter the stock. So previous 20 plus now this day's this seventh day 20 cakes, total happens to be 40 cakes. So the stock situation at the seventh day is now 40 cakes are with that particular bakery owner. Now on the eighth day, again the demand is of only 15 cakes, but the number of cakes made are 35 cakes. So previously 40 cakes, and for the eighth day, which where the 20 cakes are pending, so 40 plus 20 happens to be 60 cakes. Next, for ninth day, the demand was 35, and the cakes made were 35. And this particularly there is no cake that will be remaining pending, but for the previous day 60 cakes were remaining pending, and that will be carried forward here, right? For the 10th day, again the demand is 15, and we had made a surplus 35 surplus cakes of 35 numbers. So again 20 cakes will be pending here. So previous stock situation was 60, and this day we have on the 10th day we had added 20 cakes more. So this stock situation at the end of 10th day is how many? It is 80 cakes, right? So this is the way that you answer the stock situation if the cakes are made 35 cakes are made every day. We have been also asked that what is the average daily demand depending upon the simulated values. So we have 10 days, and we have 10 values of the simulated demand of the cakes. So if you do all the addition, this particularly happens to it has the value comes at 270, and the answer comes at 27 cakes is the average daily demand of a particular brand at that shop. So this finishes your answer. So this is the complete numerical that we can solve with the Monte Carlo simulation. Now here I agree that for the different set of the random numbers you will be getting the different values, but again if you are choosing the random numbers, or with the random numbers if are truly random, so there won't be much demand. So I had tried generating the random numbers, and basically I've got the average daily demand as 28 cakes, right? So I have generated it with the help of the random number table that is available in one of the reference book. So with that particular thing, my answer came out to be 28 cakes daily. So we can have the random numbers, but what is the problem is that you all can choose different random numbers depending upon the this particular table, but again you'll have a different answer. So it is difficult to evaluate. So in the exam, you'll be given all will be given one set of random numbers only, so that your answer matches and that is easy to evaluate. I'm hoping